All right, so get this. Today we're going to deep dive into neurodiversity and consciousness.
Oh, wow.
I've got some pretty mind-blowing research to unpack.
Sounds fun.
So, have you ever wondered if everyone experiences consciousness in the same way?
Yeah.
You know? What if my red is your blue?
Yeah. That's a question that's been around for centuries, philosophers, scientists, everyone wants to know.
Right.
We kind of just assume everyone's conscious experience is the same, but what if it's not?
Whoa. So you're saying we might all be experiencing reality totally differently?
Well, think about it. Our brains are always making predictions about the world, based on what's happened before.
Right.
Those predictions totally shape how we see things, how we interact with everything.
Okay, so my brain's predicting this chair won't collapse when I sit down.
Exactly. But now imagine a brain that's wired differently. Different experiences, it might make different predictions.
Right.
Which leads to a totally unique experience of that same chair, that same room, even this conversation.
Whoa, okay, so our brain wiring and our experiences, those shape our conscious experience.
Yeah, and there's this thing called the Embodied Predictive Global Workspace framework.
That's a mouthful.
I know, right? EPGW. It's a way easier way to say it.
EPGW.
All right, and it suggests that consciousness isn't just in your head. It's it emerges from your brain, your body, ANED, your environment, all together.
So it's everything's connected.
Exactly.
Okay, let's unpack this EPGW thing. How does it actually work? Walk me through it.
Okay, so imagine your brain as a scientist,
Okay.
constantly running experiments to predict what'll happen next.
Okay.
It uses your past experiences to build a model of the world and then makes predictions based on that model.
So my brain's testing hypotheses all the time.
Exactly. And when those predictions are wrong, that's when we get what's called a prediction error.
When I think I have more coffee left than I do.
Uh-huh. Yeah, exactly.
Yep.
Those prediction errors, they tell your brain, hey, your model needs an update. So next time you'll probably check how much coffee's left before you pour it.
So those aha moments, those are our brains learning.
Totally. EPGW says this process of predicting, messing up, and updating, that's at the core of how consciousness works.
Mind-blowing.
Okay.
But before we go too far, can you explain a couple other things? What are generative models and active inference? I remember reading about this.
Oh, yeah. Good ones. So a generative model is the blueprint your brain uses to predict what's going to happen next.
Okay.
A set of expectations based on everything you've learned.
Got it. But how does this generative model actually work? Give me an example.
Sure. Imagine you see a dog running towards you.
Yep.
Your brain's generative model, based on what's happened before, it might predict, okay, this dog is friendly, wants to play.
Right.
That prediction shapes how you react. You might smile and reach out to pet it.
But what if I had a bad experience with dogs?
Then your model might predict danger, you might get anxious or back away, and that's where active inference comes in.
Okay, so active inference is how we react based on those predictions.
Yeah, it's how we test and refine our generative models. So with the dog, active inference might be you checking out its body language, listening for growls, or even asking the owner if it's friendly.
So it's this constant back and forth, predicting acting, getting feedback.
And EPGW says this loop, this back and forth, is a fundamental part of how we experience consciousness.
Wow. So our brains are always trying to figure out the world, predicting, updating. Amazing.
Totally. And this leads us to something really cool. This new AI model called BrainLM.
BrainLM.
Yeah. It's trained on tons of fMRI data, basically brain scans.
fMRI, can you remind me what that is?
Sure. fMRI stands for functional magnetic resonance imaging. It lets us see brain activity live, it's happening.
Wow.
Yeah. It's pretty cool. It detects changes in blood flow in the brain. So when a brain area is working hard, it needs more blood. And fMRI sees that.
So we're peeking inside the brain without opening it up.
Exactly. And that fMRI data, that's what powers BrainLM.
Okay, so back to BrainLM. What can this AI actually do?
Oh, man. It can simulate brain activity like you wouldn't believe. Think predicting anxiety levels, detecting signs of PTSD, even forecasting future brain states.
Hold on. It can predict the future of our brains.
In a way. Yeah, within certain limits, of course. But the cool thing is BrainLM is giving us really strong evidence for EPGW. It's we're actually seeing how those prediction errors work.
That's amazing. Okay, but before we get too deep into BrainLM, we have to talk about the free energy principle.
Oh, yeah, that's a good one.
Can you break that down, what it is, how it connects all this?
It might sound scary, but it's actually pretty simple. The free energy principle, or FEP, it was developed by this guy, Karl Friston.
Okay.
And it's basically the math behind EPGW.
Bit brains. I'm already lost.
No. It's really elegant. FEP says all biological systems, like brains, they're driven by this urge to minimize free energy.
Free energy. What's that?
It's like a measure of surprise or uncertainty. Our brains, they hate when things don't go as planned.
So, less free energy, fewer surprises.
Exactly. FEP explains why our brains love finding patterns, making predictions, trying to make sense of everything.
So it's not just about avoiding those bad surprises. It's about finding stuff that confirms what we already think.
You got it. And this drive to minimize free energy, it shapes how we see things, how we act, even our conscious experience.
Wow, this is seriously making me rethink my brain. So how does this all relate to neurodiversity? If everyone's brain is making its own model of the world, what about people who think differently?
That's the big question, right? If every brain's unique, then a neurodiverse brain might build a model that's totally different from what we consider typical.
So someone with autism, they might experience sensory overload because their brain's making different predictions about their senses.
That's one way to think about it. And this has some really big implications for how we understand neurodiversity.
Okay, I'm ready for that.
Yeah.
But first, quick recap. We talked about EPGW, how our brains are always predicting, making mistakes, and learning. We talked about BrainLM, this AI that can simulate brains, and the free energy principle, which says our brains hate surprises. Now I'm ready to hear how this all connects to neurodiversity and how it might change how we understand different ways of thinking.
That's exactly where we're headed next. So we've been talking about how each brain kind of creates its own model of the world, right? Like a unique one.
Yeah.
Imagine if we could really understand those individual models, especially with neurodiversity.
So instead of seeing it as a deficit, we could see neurodiversity as like a strength, all these different ways of thinking.
Exactly. Think about the potential understanding these different models of consciousness.
It could change everything.
Yeah, it could revolutionize stuff like education, AI, you name it.
Okay, I'm all ears. Where do we even start?
Let's take education, for example. Imagine a classroom where we're using BrainLM to personalize learning for each student.
So instead of like everyone learning the same way, we tailor it to how their brain actually learns.
Exactly. We could use BrainLM to figure out how each student learns best. Visually, auditorily, hands-on, whatever works for them.
And then the classroom could adapt in real time. Like if they're getting bored, switch things up.
Exactly. Imagine a classroom that responds to each student's needs. BrainLM could help us create these responsive learning environments. No more boredom, no more overwhelm.
That would be amazing, especially for neurodiverse learners who sometimes struggle in traditional classrooms. What about mental health? How could this research help with stuff like anxiety and depression?
Well, right now, we diagnose mental health conditions based on what people tell us, which can be subjective, right?
Right.
But BrainLM could actually show us what's happening in the brain, so we could develop treatments based on objective data.
So we could target treatment to the specific brain areas that are causing problems.
Exactly. We could create more effective treatments. And by showing the biological basis of these conditions, we could help reduce the stigma around mental health.
This is all really exciting. But are there any downsides? BrainLM sounds incredibly powerful. Are there risks we need to think about?
That's a great question. Any powerful technology has risks if we're not careful.
So what should we be thinking about? What are some potential pitfalls?
Well, one thing is, these AI systems could become unpredictable if we're not careful about how we design them.
Unpredictable? Like how?
Imagine an AI that's so focused on minimizing free energy, on eliminating surprise, that it starts doing things that are harmful or unethical.
That's kind of scary. Like something out of a movie.
It might sound far-fetched, but it's something we have to consider. We need to develop these technologies responsibly and ethically, always thinking about the impact on society.
So it's not just about the tech itself, it's about how we use it.
Exactly. It's a shared responsibility.
Right.
Scientists, engineers, ethicists, policymakers, everyone needs to be involved.
Okay, that makes sense.
Yeah.
But let's shift gears for a second. You mentioned that this research could change how we think about AI. Could we actually create more human-like AI using EPGW and FEP?
That's one of the most exciting things about this research. Right now, most AIs are built on rules and data. They can do specific tasks really well, but they're not flexible like human intelligence.
Right, they could beat us at chess, but they don't get jokes.
Exactly. But imagine if we could build AI that learns like our brains do, using prediction, error correction, free energy minimization.
So instead of programming them with rules, we could create AI that learns from experience and adapts.
Precisely. We could go beyond task-specific AI and create AI that can learn, adapt, even be creative AI that understands the world more like we do.
Okay, now that's really interesting. But if we're talking about creating more human-like AI, the ethical questions become even bigger.
Absolutely. We're in uncharted territory here. We have to be careful.
So how do we make sure these technologies are developed responsibly? It's easy to talk about ethics, but how do we actually put those principles into practice?
That's the big question. We can't just hope for the best. We have to be proactive.
Okay. So what are some concrete steps we can take? How do we ensure this research benefits humanity without causing harm?
Well, for starters, we need to involve ethicists and social scientists right from the beginning.
So not just the tech people, but people who think about the bigger picture.
Exactly. We need different perspectives to see potential problems and come up with safeguards before things get out of hand.
That makes sense. What about transparency? If this AI is going to affect our lives, we need to know how it works.
Right. Transparency is crucial. We can't just have these super complicated algorithms that nobody understands. We have to be able to explain them in a way everyone can get.
And more black boxes.
Right.
Right.
And we have to talk honestly about the risks and benefits. This isn't just about the tech. It's about how we use it as a society.
This whole conversation has been mind-blowing. It's amazing how all these different fields, neuroscience, AI ethics, they're all connected.
They really are. And we're just scratching the surface of understanding consciousness and neurodiversity. There's so much more to learn.
We've covered a lot today, from how our brains work to the future of AI and all the ethical stuff we have to think about. If you had to pick one key takeaway, what would it be?
I think the most important thing is there's no one right way to experience the world. Every brain is different. And those differences, they make us stronger, not weaker.
That's a great point. If we can embrace those differences, not just in neurodiversity, but in how we think about consciousness and intelligence, imagine what we could achieve.
We could have personalized education, mental health treatments that really work AI, that complements human abilities. The possibilities are endless.
It's an inspiring vision. It gives us a lot to think about.
It does. And to everyone listening, if you're curious about all this, keep exploring, read, ask questions, be part of the conversation. The more we understand about the brain, the more we understand about ourselves and what we can become.
That's a perfect way to wrap things up.
Yeah.
Thanks for joining us on this deep dive into neurodiversity and consciousness.
It was my pleasure.
And to everyone listening, keep those brains buzzing. The future is ours to create.